We have ourselves a rectangle that's placed in a coordinate plane, and we want to find the missing coordinates for point B and for point D. Okay, so since it is a rectangle, we know its opposite sides are congruent to each other, the opposite sides are parallel to each other. We also know that all of these are right angles, which in terms of the lines themselves, they are perpendicular. And if they're perpendicular, then that means their slopes are negative reciprocals, neg-recip. Okay. Now this point B is on the y-axis, so its x-coordinate is automatically a 0, and we'll just call the missing y-coordinate y. How's that sound? Okay. Now another thing is if I were to draw a little right triangle here, this would be the same right triangle down here. Likewise, this right triangle would be the exact same one over here on the top side. So the bottom part of this right triangle is, according to point A, 3 units. Right? And then this top part here is 2 units. So if I flip that and put it down here, then this part also has to be 2 units, which means that the x-coordinate of point D is a 5. Now we just have to figure out what the y-coordinate is going to be. All right. This high from the origin up here to B is y. I didn't know how big it is, but from B up to the top of this, it would be, well, no, all the way up to the top, I should say. All the way up to the top, it is 5. It's 5. And that's the same thing that we got down here, that this one was 5. Okay, so the other thing that we're going to do is just use some slopes. We can find the slope between B and C. Whatever we get, find the slope between A and B and make them negative reciprocals of each other. Okay, so let's find the slope first of all between BC. So it's a change in y over a change in x. I'm going to do y minus 5 up top over, and now keep it in the same order. It would be 0 minus 2, which is negative 2. Okay. Now let's find the slope of AB. Doing the same kind of thing. So this one would be y minus 0, which is just y, over, keeping it in the same order, y minus 0 would be 0 minus 3, so a negative 3. Now I need to force these into being negative reciprocals. So I'll write down this one, which is y minus 5 over negative 2. And now I'm going to set it equal to the negative reciprocal of this. It's already negative, so I'll make it positive, and then I will flip it. So I'll set it equal to 3 over y. And now it's a proportion, and we solve proportions by cross multiplying here. So I'll distribute this y across the top here, this y times y, and y times negative 5 to get y squared minus 5y is equal to negative 2 times 3, negative 6. Add the 6 over. Y squared is equal, or y squared minus 5y plus 6 is equal to 0. And then I have to factor that guy. When I factor it, multiplying up to positive 6, adding up to negative 5, it's going to be y minus 3 and y minus 2. And since both of these are lying to us in the parentheses, that means that y could possibly be either 2 or 3. So we have 2 different values here. It's possible that this is the point 0, 2. So that makes this piece here equal a 2. And what would be left over for this part up here? A 3. To make the whole thing equal to a 5, which means that this part down here is also equal to a 3. Whoops, not this piece. That's already a 2. This piece was 3. So our first coordinate for D then would be 5, 3. So here's one possible answer, 0, 2, together with 5, 3 for B and D. But I could also make y equal to 3. I'll do this one in a different color. So let's say that this one is equal to a 3. And since the whole piece must be equal to 5, then that leaves this piece being a 2. And down here at this other right triangle makes this a 2, which means that this point D, its corresponding point would be 5, 2 with 0, 3. So here are our two sets of answers for this.